Hi, in this video we'll learn how to take the derivative of an exponential function. Okay. Alright, so our rules here are the derivative of e to the x is simply e to the x. And now if I take the derivative of e to the u, it is simply e to the u and then du dx. Right? So I have several examples I'm going to go through here. Alright, here I have e to the minus x squared. If I take u to be minus x squared, then I know the derivative dy dx of this is going to be e to the minus x squared. Okay, notice e to the u equals e to the u. And now I have to take the derivative of my exponent, which is going to be minus 2x. So I could probably write this out front, minus 2x e to the minus x squared. Or remember, we don't really like negative exponents in the math world, so we could write this minus 2x over e to the x squared. Another example here. Well, remember that if we have a constant out front, we can simply bring it out in front. All right, so this is going to be 3. All right, and now I'm going to have e to the u, so it's simply e to the 1 minus x squared, and then I have to take du. So I have to take the derivative of 1 minus x squared, which is going to be negative 2x. My negative 2x I can multiply by the 3, and I end up with minus 6x, and then e to the 1 minus x squared. All right, let's try another one. Now remember, your old rules have not gone away. Here I'm multiplying two things. All right, so I'm going to have to go back to my rules before. Remember, 1 as is, take the derivative of the second. E to the x is e to the x. All right, and then it's plus 2, which is e to the x, derivative of the first, which is just 1. So remember that the product rule has to be applied as well. Okay, and now I can simplify this further by factoring out an e to the x, and I simply am left with x plus 1. Okay. Forgive my sloppiness, I should be writing dy ds. Okay, now I want to take the derivative of e to the minus 3 over t squared. Again, the same rules. The derivative of g of t is going to be, again, e to the u, so I'm just going to write it as is, minus 3 over t squared. Now you might want to rewrite this and think of it as minus 3t to the minus 2, just so you can do the math, okay, a little simpler, right? And now we take the derivative of this part. Okay, so recall the derivative of t to the minus 2, I bring the minus 2 up here, times the negative 3 would become 6, and then I take one less of that, so it's 6t to the minus 3. Okay. And now basically I can put my t cubed in the denominator. I can move this down to the denominator and make it a positive exponent as well. So for my final answer, I can write this as 6 over, okay, so 6 is going to stay in the numerator, t cubed in the denominator, right? I'm going to drop that down to the denominator so it becomes positive. I'm going to drop this down to the denominator so it becomes positive. 3 over t squared. Now I have two more examples, okay? Again, I just want to point out that the old rules, all right, may or may not apply. Right? So if I want to find the derivative of this, dy dx, the first thing I can do is rewrite this as the natural log of 1 plus e to the x minus the natural log of 1 minus e to the x. Again, applying those rules of exponents, or properties of logs, sorry. Right? And now when I take the derivative of this, I can take the derivative of each part. Natural log 1 plus e to the x minus dy dx, natural log of 1 minus e to the x. Okay, and so in this first part, recall that the derivative of the natural log is just 1 over that. Okay, remember it's the derivative of u, or u prime over u. Okay, So this is going to become the derivative of u, which is 1 plus ex, so it's e to the x, okay, over my u, which in this case is 1 plus e to the x. And now we're subtracting here. Again, same idea. If we let this inner part be u, it's the derivative of u, which would be minus e to the x, okay? Because the derivative of 1 minus e to the x is just minus e to the x, all over that whole thing. Minus e to the x. And now if I want to get fancy, I can combine all this underneath a common denominator by multiplying this by 1 minus e to the x top and bottom, and multiplying this one by 1 plus e to the x top and bottom. If I do that, I end up with e to the x minus e to the 2x plus e to the x plus e to the 2x all over 1 plus e to the x 1 minus e to the x. Looking at my numerator, I see that this term and this term cancel out, but I can combine these. They're both e to the x's. So we end up with 2 e to the x all over 1 plus e. Oh, I'm sorry. It's minus, because you can actually FOIL out that denominator, right? And notice that you would end up with 1 minus e to the 2x. Okay. And now in my last example, recall that we can pull a constant out front, so we can pull the 1/2 out front, and then we can just take the derivative of e to the x minus the derivative of e to the minus x. So we've still got our 1/2. It's going to be out in front of this whole thing because we factored it out. And now the derivative of e to the x is simply e to the x. I'm subtracting here, but the derivative of e to the minus x is going to be minus e to the minus x. My two negatives will cancel, so it's just plus, again, that 1/2's out front, e to the minus x. Okay. And now my answer, this would be my final answer. Okay, I hope that helps. Do some examples of how to integrate exponentials.